Okay, as you can see, we're not in the classroom again today, so we're going to take a look at a PowerPoint on weathering. Our objective in this section is to identify and describe the two types of weathering, those being mechanical and also chemical. Okay, so our first question is, what is weathering? And the answer is the breakdown of rocks into smaller pieces. And there are two types. There's chemical and mechanical weathering. Mechanical weathering is a type of weathering in which rocks and minerals break down into smaller pieces. This process is also called physical weathering. Mechanical weathering does not involve any change in the rock's actual composition, only changes in its size and shape of the actual rock. A variety of factors are involved in mechanical weathering, which includes changes in temperature and pressure. Okay, we have mechanical weathering, and we're going to focus on ice wedging. As you can see in this picture, this gigantic boulder is cracked into two pieces, and it occurs when water squeezes out into a crack within a rock. The water freezes and expands and actually cracks the rock in two. So temperature does play a major role in mechanical weathering. When water freezes, it expands. It increases by a volume, its volume actually increases by 9%, as you can see in the picture. If the temperature drops to a freezing point, water freezes, it expands, exerts pressure on the rock, and causes the crack to actually widen. This is called either ice wedging or frost wedging. Another type of mechanical weathering is when plant roots, like the one that's shown, act like the ice and they exert pressure onto the rock. And as the roots continue to grow and try to mine the minerals from the rock, they will expand. And as they expand, they exert pressure onto the rock and they crack the rock into pieces. Yet another type of mechanical weathering is known as abrasion. It occurs when rocks and sediment grind against each other, wearing away the exposed surfaces. This can happen with both wind and also water. Now we're going to switch gears into the other type of weathering, which is chemical weathering. This is the breaking down of rocks by changing their chemical composition. Major agents include water, acids, and also air. Okay, so now let's take a look at the chemical weathering and what part of the world chemical weathering tends to be most prevalent. The climate of an area is actually a major influence on the rate of chemical weathering as to what kind of materials are there. The variables involved are the climate, in particular the precipitation, the temperature, and also evaporation. The interaction between temperature and precipitation has the greatest effect on the region's rate of weathering. Chemical weathering occurs readily in climates with warm temperatures, abundant rainfall, and also lush vegetation. When carbon dioxide and water combine, they form carbonic acid, which can be found in precipitation and is also known as acid rain. The formation of this carbonic acid is actually H2O plus CO2, which yields H2CO3. This carbonic acid reacts with minerals such as calcite and limestone and also marble to dissolve rocks. For example, limestone caverns can form when carbonic acid dissolves the calcite in the limestone rocks, and that's what gives you caves. In addition, we also have chemical weathering that's from acids that are found within roots of plants and also within lichen. As shown in this picture, that's actually lichen that's on a rock, and as it sends its root system into the rock, the acid will actually break down the rock. Another form of chemical weathering is actually oxidation. Iron in rocks and minerals combines with the oxygen in the water and the air, and as a result, the minerals actually fall apart more easily. And that concludes the section on weathering. Well, as you can see, we're not in the office again. And today, I've got a special treat for you. We're going to be taking a look at a PowerPoint on weathering. Sounds good.